Here's a couple of Sennheiser e945 handheld wireless microphones, which have been around for a long time and are a fairly popular choice for low to mid-range applications. They're pretty solid for the price, but they do seem to have a weakness in that the power button breaks fairly easily. This is largely because the button is so small that people use pens and pencils to push it, but I have massive sausage fingers and I have no problem pressing it, so I don't really understand why people do that. Anyway, both of these microphones have broken power buttons, so we'll need to get in and replace those. You start by opening the battery compartment and removing the 3 Torx screws holding on the bottom cap. This gives access to the circuit boards in the bottom of the microphone. Next, you have to remove the Torx screw from the little circuit board that connects up to the microphone capsule. Then you disconnect the flat flex cable connecting that board to the other 2. Then it's just a case of removing that circuit board, which is quite fiddly. You just have to sort of pull it out and wiggle it side by side until it comes free. Now that we have access to the display board as well, we remove its Torx screw too, and also disconnect its flat flex cable from the board underneath it. This gives us access to the switch, or rather where the switch would be if it hadn't been broken off. Now, first things first, we need to remove the old solder from the pads, as well as any metal legs or anything like that that may have got stuck on there. So I'm just applying a little bit of flux to the pads, and then I'm going to use solder braid to just wick off the remaining solder there. So we've got nice clean pads to solder onto later. Okay, just got to clean the pads off with some isopropyl alcohol to get rid of the old burnt flux. Mop it off with a bit of paper towel. Now, everybody likes to solder surface mount components their own way. Personally, what I like to do is put a blob of solder on one of the pads, then whilst keeping the solder melted, bring the switch onto the pad and then just release the soldering iron to hold the switch in place. You can then solder the remaining 3 pads just at your own leisure. So now we've done that, it's just a case of reattaching the flat flex cable and the other circuit board, screwing it back in, and then carefully reinserting the little slide-in circuit board there, which is slightly easier than taking it out, but not much. Just going to attach its flat flex cable as well, and then we're ready for testing. So we'll need to put some batteries into it. Now, I've just noticed that the battery compartment is absolutely full of caked-in battery acid. Someone's used some cheap batteries in this and they've leaked everywhere and it's all made a horrible mess. So we'll have to clean that out first. Luckily, there doesn't seem to be much corrosion, but if we left it in that state, it would only be a matter of time. So just using a stiff brush and some isopropyl alcohol, I'm just going to slowly scrape and clean the inside of the battery compartment until we get rid of all that nasty, horrible goop that's clogging it up. Now that took an irritatingly long time, but it's now all nice and clean. So we'll put 2, well, not fresh batteries I stole out the other microphone, see if the device powers on. And yes, it has. Green light comes on, the display's gone on. Now if I flick the end of the capsule, you can see that the audio bars are lighting up in the display, so that must mean everything's all connected and working, which is great. Now, I don't have any reason to suspect there's any other problems with this microphone, so I'm not going to bother testing it with the receiver just yet. I'm just going to put the device back together and we'll test it once we've done all that. Now, the other part of the switch is this little red rubber actuator thing that sits inside the end cap of the microphone. Now, it's got to be sort of positioned carefully over the hole, and what it does is it just presses down on the little switch. I suspect probably the reason these things break is those red things fall out, and then people start using a pen or a pencil to push directly at the switch, and eventually they end up knocking it off the circuit board. Yeah, just have to carefully lower the microphone into the end cap, and yeah, that's the red button sticking out now and all looking good. Just have to put the 3 screws in that hold in the end cap, and we can test it with the receiver. Now, this is the receiver that it came with. It came with this odd little microphone to 5-pin DIN cable. I've no idea what that's for. I think it maybe came out of a church, and I know they tend to have oddball PA systems installed in the 1960s and 70s, so Possibly it's something to do with that, but we'll have to go and get a slightly more appropriate cable, one that will actually plug into something I have in the workshop. So yeah, I'm just going to use an XLR cable. Now, what we have to do is make sure the frequency on the receiver matches the frequency on the handheld microphone. On the microphone it's 839.1, but the receiver says 843.4. So we'll have to change the receiver to be on the same channel. So 839.1, yeah, there we go. Store that, and yeah, that should be us. So now we give it a quick test. Yeah, that seems to be working. You can see if I tap it, then the audio displays on the screen of the receiver, and also it's coming through the speakers, but you're not going to hear that. So yeah, just got to put the microphone back in its box, wrap up all the cables neat and tidy for the customer, and yeah, send it back on its way. I'll do the other one when I get back from the pub.